Hi everyone, this is Mrs. Musoff here. And today we're going to run through the change of base properties. So we've learned about a few different properties of logarithms. This is the last property, and I think it's one of the easier ones. It's originally really was just meant to help us evaluate logarithms using our calculator. So the logs that we can't do by hand, being able to type them into the calculator. And so the change of base property, it allows us to take a given base and change it into something new. So you can see here this change of base property. It says the log base b of a is equal to the log base c of a divided by the log base c of b. So what we've basically done is taken this base, changed it to a different number, and then put the base as the argument in the denominator, and then the original argument stays as the argument in the numerator. Alright, so we're assigning a logarithm a new base and then kind of splitting up those two pieces. Now, you might look at this and wonder why that would be helpful, but the reason is because there are two bases for logs that we see most often, and I'm going to show this to you on your calculator. If you take a look at your calculator, alright, you can see that there are actually two log buttons on your calculator. One of them is right next to the 7 where it just says log. Alright, that's a common logarithm, and common logarithms have a base 10. So this logarithm has a base 10, and it's used a lot just for convenience sake, because a common log, a base 10, you don't have to write the base in. When it's a base 10, it's assumed. Kind of like when there's an exponent of 1, you don't have to write the actual 1. Alright, it's just like that. The second logarithm button on your calculator is right below it. It says ln. It stands for a natural logarithm, and a natural logarithm is a log with a base e. Right, if you ever forget the bases, they're right above it. Okay, so a common log is base 10, a natural log is base e. And it used to be that calculators only had these two buttons to evaluate logarithms, and so if you wanted to evaluate a logarithm on your calculator, you had to turn it into a base 10 or a base e, because those were the only buttons on your calculator. And so that's where the change of base property comes in handy. And the idea is, okay, yes, you can change it to any base you want, but a lot of times it's most convenient to change it to either a base 10 or a base e. So the way I could do that with this, if I had log base b of a, let me just erase this so we can see it. If I had log base b of a, I could change it to be a common log, which would be a base 10, and then I don't have to write the base. I would just do the log of a divided by the log of b. And it's very convenient to type into the calculator then. And it works the same way if I wanted to use a natural log, a base e. I would just write natural log ln of a divided by the natural log of b. Alright, so these are the ways that we most commonly will use the change of base, at least for right now. Okay, so I'm going to do just a couple examples to kind of review that with you. It says rewrite using the change of base, and then use your calculator to evaluate. So in number 1, this says log base 12 of 17. And as is, we would have no way to type a base 12 into our calculator, because again, we only have a base 10 and a base e button. And so because of that, right, I'd be kind of stuck, especially since we can't do it the non-calculator way, which is rewriting it. Because if I tried to rewrite this, and don't write this down, but if I tried to rewrite this, it would be 12 to the x equals 17. Well, there's no way to break down 17 or 12 to get them to be the same where I could actually solve. And so that's why we need change of base in order to evaluate this. So when I notice that those two numbers you're not going to be able to break them down, or when the directions say rewrite using change of base, what I'm going to do is I'm going to make it either a base 10 or a base e. I prefer base 10 for right now. So I'm going to do base 10, which means I don't have to put the base, so it's just a log. And then I'm going to give it to the 17 first, divided by, and then I'll write another log with the same base, so base 10. I'm not going to write the base, it's implied. And then we'll do the original base, which is a 12. All right, and I always remember the order because I know the base should go on the bottom, so the original base number should be on the bottom of this fraction. All right, and now we can type it in our calculator. So I would type log of 17, remember to close the parentheses here, divided by log of 12. And I would get 1.14, and so that would be how I could evaluate. Alright, since the answer was a decimal, I know there would have been no great way to do it by hand or without the calculator. This is really our only option. Alright, same thing for number 2, log base 2 of 87. Again, I can tell just by looking at it, 87 is not going to break down where rewriting it would help me. So I have to use change of base. So I'm going to just do, again, a common log, and I'm going to give it to the 87 first, and then the original base goes on the bottom. So log 87, log 2. It kind of looks like you're distributing it, right? It's not quite right mathematically, but that's what it looks like, so I can understand if that's what helps you remember. Alright, and again, I'm going to type it in my calculator. So common log of 87, close parentheses, divided by common log of 2. Alright, and this time I get 6.44, and so that would be my answer. Okay, this change in base property is going to become really important when it comes to solving, so definitely kind of use that when we get to that point. Alright, thanks for watching.